Hey! I'm Haley. I'm with the Truckee Meadows Parks Foundation Student Stewards Program, and today we're going to be learning about the fascinating world of dry ice. And we're going to be doing that by making some fantastic tasting dry ice cream, or as I like to call it, dry cream. Here's what I've got with me today.
Here's what I've got in my scientist bag: milk, honey, jam, dry ice, hammer, safety glasses, gloves, bowl, spoon, and if you're going to try this at home, you'll also need an adult. So we're making dry ice cream, but what exactly is dry ice? Dry ice is solid carbon dioxide. Carbon dioxide might sound familiar to you because it is what we exhale when we breathe and what plants inhale through photosynthesis. In both of these processes, we are experiencing carbon dioxide gas. However, when the temperature gets below -109 degrees Fahrenheit, carbon dioxide gas solidifies into what we can now call dry ice. When the temperature rises above -109 degrees Fahrenheit, dry ice starts turning back into a gas. Scientists call this sublimation, and we can see this happening below. The sublimation process is interesting because carbon dioxide is going directly from a solid to a gas. Now that we know more about the unique properties of dry ice, let's apply them as we make dry ice cream.
Alright, we're going to start off by taking our oat milk, or whatever kind of milk you're using. Now to sweeten it up, we're going to add a little bit of honey.
While we stir, think about what will happen when we add in the dry ice. Will our ice cream mix be soggy? Will it turn into a gas? What do you think will happen? As you can see here, our carbon dioxide is starting to sublimate, turning into gas bubbles and bubbling away. Let's take a closer look. Whoa, look at all those bubbles. What's happening in there? Well, before I added the dry ice, our ice cream mix was a liquid with a temperature of 40 degrees, about the same as the inside of the fridge. Ice cream has this ideal creamy texture at around 14 degrees, so our mix was too hot. Scientists think of cold as the absence of heat, so when we added the dry ice, and remember it's at maximum -109 degrees, it started taking as much heat energy as it could from our ice cream mix. And once the dry ice started warming up, it began sublimating and turning into gas. Our ice cream mix is losing a lot of heat very quickly, so it is going to reach our ideal texture and temperature soon. Let's see how it turns out.
Did you know that dry ice was invented in 1835 by the French inventor Atelier? Some of his other ideas include a smokeless stove as well as a diving wheel so that cars could drive across rivers. That's pretty cool. However, it wasn't until 1924 when the US inventor Thomas Slate applied for a patent, coined the name dry ice, and began selling it commercially. Dry ice is used by all kinds of scientists. For example, tiny dry ice pellets are used by firefighters to put out fires because the carbon dioxide displaces oxygen, one of the three things that a fire needs. Dry ice is also used by marine scientists and other environmental stewards to clean up oil spills. They'll drop in some dry ice, the oil will conglomerate and freeze, which makes it a whole lot easier for scientists to remove the oil from the oceans. Today, it plays an especially important role because the COVID-19 vaccine requires an extremely low temperature for storage. And you know what is extremely cold? Dry ice. And of course, dry ice is used by culinary scientists like you and me to do all sorts of fun things like carbonate beverages, preserve foods, and make ice cream.